Hey everybody, welcome to your second video notes of the year. This is on systems of equations with 3 equations in them and 3 variables in them. So this video is going to be an introduction to systems like this, and it's going to show you 2 different types of systems like this to solve. They're the easier kinds. We'll save the most difficult kind for class on Monday so we can solve them together. So while you're doing this, make sure you have your notebook open and ready so you can copy down all the notes and the pictures and write the math down. And then in class you'll have this for your reference whenever we do the harder kind. Before we get into systems with 2 equations, before we get into systems with 3 equations, let's compare them to systems of 2 equations in 2 variables. So you have been solving systems with 2 variables, x and y, in this standard form. You've been doing that for a few years now. You're well aware that whenever you graph this, it's a line, and it's in two-dimensional space. You just have your x and your y axis. It's flat against your page. Nothing is sticking out of the page at all. And it's called the Cartesian coordinate plane. That's what you graph your line on. The solution, there's 2 ways to think of it. It's either the point of intersection of 2 lines, or it's an ordered pair whenever you solve it algebraically. Now, this point of intersection only happens if there's one solution, if it's consistent and independent. If the lines are parallel or the lines are the same, you'll either have no solution or infinitely many. Let's jump to linear equations in 3 variables. We're going to add a z, and I'm now in this standard form, ax plus by plus cz equals d. Now, whenever I graph a linear equation in 3 variables, it's going to look quite different than what you're used to. It's actually going to end up looking like a plane because we are now in 3-dimensional space. So let me show you how this is done by hand, and then I'll show you a software where you can graph it. It's a lot easier to picture this whenever you're using computer graphics or a computer graphing system. It's hard to do it by hand. So let's take this equation, 3x plus 4y plus 6z equals 12. Whenever you solve for intercepts, it's the exact same as before. It's just you have a 3rd variable. So for my x-intercept, not only is y equal to 0, but z is also equal to 0. And when I solve, I get x equals 4. In a similar manner, for the y-intercept, x and z are 0, y is 3. For my z-intercept, x and y are 0, z is 2. So watch how I plot this. First of all, whenever you draw your plane, it's different. Your vertical one is now z. That's how most people label it. The one up and down is z. The horizontal one is y. And you actually have a 3rd axis. And picture this as if it were sticking straight out of the computer screen at you. This is how most books will draw it. The positive x-axis is coming out. The negative x-axis is like going into the computer or going into your paper. So let's plot our intercepts. It's the same exact as before. You just have 3 planes now. So here's x equals 4. I'm coming out 4 spots. Y equals positive 3, and z equals 2. So whenever you do this, after you plot your intercepts, all you do is you connect them like this, and it would be a plane like this. Now obviously the plane keeps going, it's infinite, it's just this is one way. We can't make it look infinite on our paper. This is how, probably the best you can do by hand. And as you can see, it leaves a lot to be desired. It doesn't look very good, but I'll show it to you on Maple in 1 second here. Now, whenever you graph a system of it, sometimes the solution will be a line, unless some of the planes are the same, or some of the planes never intersect at all. And the solution, it's not an ordered pair anymore. It's an ordered triple, x, y, and z. And when you plug x, y, and z into the system, it makes each equation true. So let me jump over to something called Maple here. If you take math classes in college, you'll most likely end up using this software. There's a couple different things you can use. Maple is one of them. It lets you do pretty much any kind of math and visuals as well. So what I'm going to do is graph it. 3x plus 4y plus 6z equals 12. I'm going from negative 10 to 10 and negative 12 to 12 with z. So you can see here, it's a lot easier to picture this as a plane. It's kind of like a sheet of paper. Again, remember, this is an infinite plane. The only reason it doesn't look infinite is because my screen is only so big. And if you could let it keep going on forever. Another way is to solve for z. So it's 2 minus 1/2 x minus 2/3 y. We'll be doing this in class. We'll practice it more. And you can also use plot 3D command. And it's just another way to enter it in. It's another command that your computer can do. And this is the plane. This is what they really look like. So let me jump back to the notes. Okay, so make sure you have this whole page copied down because I'm going to go to the new screen, so pause the video if necessary. Here's just an example of a system with 3 equations. There's infinitely many kinds. This is just one. We'll start solving these on Monday and Wednesday. We're not quite ready for those yet. We're going to start off with a easy kind first. There's 3 different types. The first kind, I just refer to it as a staircase because it kind of looks like a staircase. That's not a technical term. The method we use is back substitution. That's a more technical term. If you say back substitution, people will know what you mean. So this kind, you know it's the staircase kind whenever one equation has 1 variable, another one has 2 variables, another one has 3 variables. So you go from small to large. This is going to be the easiest kind because one of them is pretty much given to you right here. I know z is 8 right off the bat. So I back substitute into my second largest one with 2 variables. And I have 4y plus z is 0. I plug my z in, I get y is 2. Now that I have 2 of those variables, I back substitute into the last one. Here's my work here. Copy that down. Make sure you can follow it. I get x equals -1. And here is my ordered triple. So in your notes, write this system down right here. I'd like you to take a minute and try it. It's not hard. Do back substitution. You're given x right off the bat. Get y and z. Write it as an ordered triple. I'll show you the answer in class next time I see you. The other type, this is the last slide, the other type I want you to do is when only one of the equations has 1 variable. The other 2 equations have all 3 variables. What you'll do is you're always going to have 1 variable that's kind of given. In this case, it's this one. You're pretty much given that z is 2. You just divide by 4. And then you plug that given variable back into the other 2, and then you'll solve it like a normal system of 2 equations. So here's my work. I know z is 2, so I take 2 and I plug it into here and here. So here's my work. Now I don't just want to leave it like this. I want it in the form ax plus by equals c. So I take my constant and I move it to the other side. So I do 5 minus 2 and I do -2 minus 2. And I end up with x plus y is 3, and 2x minus 3y is -4. Now I'm going to solve this using elimination because I usually prefer elimination to substitution. I'm going to multiply this by 2, and I end up with this. Now I need to subtract so I can eliminate x. I get 5y is 10, and y is 2. So now I have z and y. All I need is x. So pick one of these guys to plug into to get the last variable. So you have y and z, you need x. I chose the first one because the coefficients are smaller. They're all 1. Plugged them in, I got x as 1. So here is my ordered triple. And we'll practice this more on class, and then I'll show you the third kind, the hardest kind. Have a good weekend.